Welcome to an algebra tutorial video learning about linear equations and getting into understanding perpendicular lines and how two lines and their slopes and intercepts and equations all relate to each other graphically. So if you remember, perpendicular lines are two lines that cross each other and they form a 90-degree angle. Think about the corner of a square or the corner of a rectangle. Essentially the sides are perpendicular lines that are connecting. So in this problem, I want to go over how do we determine if two linear equations are perpendicular to each other. So I got a couple lines here, a couple equations. We could graph them and visually see what's going on. But if you want to show two lines are perpendicular to each other, then what you're needing to do is get into the slopes. Find the slope of each line, compare them to each other, and if you remember, perpendicular lines have slopes that are negative reciprocals. So I'm going to write down the side here. We're looking for negative reciprocal slopes, comparing them. So if one's positive, one's negative. If one's 1/5, the other is 5/1. We're looking for negative reciprocal slopes. And if we have that, then we know they are perpendicular lines. Their rate of changes are opposite of each other. All right, so let's take these two equations. If I want to know what the slope of them are, the easiest thing to do is just put them into slope-intercept form, solve for y. So we're going to do that for both of these. Let me draw a line down. It's not a crooked line, but it'll work. And let's rearrange this first one to get y by itself. So I've got this 8x term. I'm going to subtract 8x from both sides. We're just going to crunch out our algebra. You can see how algebra is really handy, just being able to do stuff with both sides of the equation. So got subtracted 8x from both sides. Now we've got negative. Make sure we don't lose that negative sign. Negative 6y equals negative 8x plus 1. So we're just rearranging this thing to get y by itself. Now I got y times negative 6, so the opposite of that is to divide by negative 6. And if I do it, I need to do it to everything on both sides. So negative 6 divided by negative 6 leaves me with just y by itself. Negative 8 over negative 6 reduces down they're both negative, so it turns into a positive. And 8 over 6 reduces down to 4/3 x minus 1/6. Okay, there's the first equation rearranged. It got a slope of 4/3. All right. So now we need to work on this second equation. Let's see how its slope compares. Let me draw a line. Again, the line just helps me make sure I'm doing things equally to both sides of the equation. And I'm going to start off by distributing this 2/3. So I've got a parentheses here. I don't want that. So we've got 2/3 times 9. 9 divided by 3 is 3 times 2. So 2/3 of 9 is 6. And then minus, and 2/3 times 2x. I can think of that 2x is 2/1. So 2 times 2 gives me 4. 3 times 1 gives me 4/3 x, negative 4/3 x. Still got the y minus 2 there. All right, let's now add 2 to both sides. So I can get y by itself, minus 2 plus 2, opposite operations. And y equals 6 plus 2 is 8, minus 4/3 x. And I can do some rearranging here. Again, to put it in the slope-intercept form. Doesn't matter the order you add things, so we can rearrange that to y equals negative 4/3 x, put the x term first, and the plus 8 at the end. And there we go, we got that equation all in slope-intercept form. Well, what's the slope? The slope on this one is negative 4/3. So now how do they compare? Well, one is positive, one is negative. So we got the negative part, check. And one is 4/3, the other is 4/3. And oh, I'm bummed out. It does not work out. So to be negative reciprocals, I would actually have to have this one be 3/4. So it's close. You may initially jump at it and think, oh, they're the same. So yes, one's positive, one's negative. We've got it, perpendicular lines. But this one actually, to be perpendicular, had to be negative 3/4. 4/3, 3/4, that would satisfy the reciprocal part. So although our slopes are negative, they're not reciprocals of each other. So are these two lines perpendicular? No, they are not. And in fact, this line needed to be, the one in red at the end there needed to be y equals -3/4 x plus 8. That would be a perpendicular line. All right, hopefully that's a helpful problem for you to see. And in comparing, are two lines perpendicular, are they not? Again, you just want to get to what is the slope for each line. Once you have that, then you can compare the slopes, see if they're negative reciprocals, and then determine if they're perpendicular or not.